Laser beam profile alignment. The Spectra system needs to align optical devices to get the following beam profile. Most of low energy problems happen by abnormal beam profile. Therefore, service engineers should check the beam profile first when checking the system. The beam profile should be as the following sample at the end of the arm. The following is the beam profile when the beam mood is bad. The system here needs alignment and optics cleaning. Points of alignment. Oscillator chamber. The oscillator chamber has two alignment components, which are OC lens and HR lens. To get good beam profile after OC lens, follow alignment procedures below. 1. Set the fluence as much as it can mark on the carbon paper. 2. Check the beam profile after OC mirror on carbon paper. 3. Find the weak point on the carbon paper. 4. If the weak point is on the y-axis, adjust the vertical alignment points of the OC and HR lens. 5. If the weak point is on the x-axis, adjust the horizontal alignment point of the OC and HR lens. 6. After adjusting the alignment points, the beam profile should be checked in every process. The amplifier chamber has two alignment components, which are bending mirror 1 and 2, and are used to get good beam profile at launch mirror. The alignment procedures are: 1. Set the fluence as much as it can mark on the carbon paper. 2. Check the beam profile before launch mirror on carbon paper. 3. Find the weak point on carbon paper. 4. If the weak point is on the y-axis, adjust the vertical alignment points of the first bending mirror. 5. If the weak point is on x-axis, adjust the horizontal alignment points of the first bending mirror. 6. After adjusting the alignment points, the beam profile should be checked in every process. 7. Check the beam position. It should be located at launch mirror center. 8. If the beam is not in the center of the launch mirror, adjust the bending mirror 2 to place it on launch mirror center. 9. Repeat above procedure 1 to 8 for making well beam profile and center position on launch mirror. 10. After amplifier chamber alignment, service engineer needs to set up the energy at low level because the high energy could damage the rod. The launch mirror alignment has 3 alignment points to get good beam profile at the end of the arm. Follow the following alignment procedures. 1. Set the fluence as much as it can mark on the carbon paper. 2. Install the arm without any handpiece. 3. Check the beam profile at the end of the arm on carbon paper. 4. Find the weak point on the carbon paper and align the launch mirror to make it circled beam profile. 5. After adjusting the alignment points, the beam profile should be checked in every process. 6. Repeat the above procedure until finding circled beam profile. KTP alignment. The KTP alignment goal is to get the best efficiency of 532 nanometer output energy from the input 1064 nanometer energy. Normally, the 532 nanometer energy is 400 millijoule when 1064 nanometer energy is 700 millijoule. The efficiency percentage is approximately 65% to 70%. There are 4 alignment points for the KTP. The procedures for KTP alignments are: 1. Check and record Q switch at 1064 nanometer energy before KTP. 2. Measure the energy after KTP. 3. Compare input energy before and after KTP. 4. If the 532 nanometer energy is less than 50% of the Q switched 1046 nanometer input energy, align the KTP position to improve the KTP efficiency by rotating the KTP as in photo 2, hard alignment, or by alignment of the 3 points as in photo 1, soft alignment. 5. Repeat the above procedure until finding maximum KTP efficiency. Q leakage. The Q leakage is abnormal energy when the system is operated in Q switch mode. It can make low energy at Q switch 1064 nanometer and 532 nanometer wavelength. The goal of the leakage alignment is to make it below half millijoule. There are two components to decrease the Q leakage, which are Puckle cells and quarter wave plate. 1. Check the Q leakage after beam profile alignment with the following settings. A. Set up the wavelengths to the Q switched 1064 nanometer. B. Set up the fluence to the maximum on the spot size 7 mm. C. Switch off the high voltage button on high voltage control mode. D. Measure energy at the arm post. 2. If the measured energy is over 300 millijoule, do the leakage alignment by the alignment point of the quarter wave plate as in photo 1. 3. If the measured energy is below 300 millijoule, adjust Puckle cells alignment point as in photo 2. 4. Repeat the above procedure until the measured energy is below half millijoule.